Hi, welcome back to Master Your Science channel. We'll be starting off the Master Your Chemistry series by looking at topic 1 of the Cambridge IGCSE syllabus, States of Matter. Section 1.1, Solids, Liquids and Gases. According to the IGCSE Cambridge syllabus for examination from 2026 to 2028, by the end of this topic, you should be able to do the following. Number 1, state the distinguishing properties of solids, liquids, and gases. Number 2, describe the structures of solids, liquids, and gases in terms of particle separation, arrangement, and motion. Number 3, describe the changes of state in terms of melting, boiling, evaporating, freezing, and condensing. Number 4, describe the effects of temperature and pressure on the volume of a gas. Number 5, explain the changes of state in terms of kinetic particle theory, including the interpretation of heating and cooling curves. Number 6, explain in terms of kinetic particle theory the effects of temperature and pressure on the volume of a gas. So, what are the properties of solids, liquids, and gases? Solids have a surface boundary and a fixed shape. Liquids have a surface boundary and they take up the shape of the container in which they are placed. Gases have no surface boundary and they fill up the container they are placed in and have no fixed shape. Let's take a look at this question from the IGCSE specimen paper. It says, describe the separation, arrangement, and motion of particles of element X in the solid state. Note that we do not need to know what X is in order to answer this question. It is sufficient to know that it is in solid state. A solid has particles that are tightly packed It has a regular arrangement and its particles vibrate in a fixed position. If X was in a liquid state, then its particles would be loosely packed, have an irregular arrangement, and are able to slide over each other. If X was in a gaseous state, then its particles would be far apart, randomly arranged, and move at high speeds. So, what are changes of state? Imagine a very hot day in October. You take out your chocolate ice cream from the freezer. It is frozen and you take a bite to cool down. The delicious ice cream melts in the warmth of your mouth. This is an everyday example of change of state. The solid frozen ice cream changes. That is, it melts to become a liquid. This question, also taken from the specimen paper, says, element X can undergo the following physical changes. Part A says, name each of the numbered physical changes shown in figure 1.1. Number 1 shows the change of state from solid to liquid. This is melting. Number 2 shows the change of state from gaseous state to liquid state. This is condensation. Number 3 shows the change of state from liquid state to solid state. This is freezing. Number 4 shows the change from liquid state to gaseous state. This is boiling. This can also be evaporation. However, boiling and evaporation are different. Let's look at the next question to appreciate this difference. The question says that one difference between boiling and evaporation is the rate at which the processes occur. State one other difference between boiling and evaporation. So this question already gives us one difference, which is the rate at which the processes occur. So boiling is faster than evaporation. And then we are asked to state one other difference between boiling and evaporation. We'll discuss two more differences here. The first difference is that boiling takes place throughout the liquid, whereas evaporation only takes place on the surface. So we've got throughout the liquid, then on the surface. The second difference is that evaporation takes place at any temperature, whereas boiling takes place at a specific temperature, which is the boiling point. For example, pure water will only boil at 100 degrees Celsius, but if you spill some water, it will slowly evaporate over a range of temperatures. How is the volume of a gas affected by temperature and pressure? This next question is from the February-March 2025 paper, and it says, the diagrams show containers of gas at the same temperature or containers of the same size. Which container contains gas at the highest pressure? The key things to note here is that the gas is at the same temperature and it is in containers of the same size. Therefore, the container with the highest pressure is the one with the highest number of particles in a given volume, and that is container A. An increase in the pressure of a gas means that its particles are closer together, and this causes the volume to decrease. More particles occupy a smaller space because they are closer together. The volume of a gas will increase as the temperature increases if the gas is in a container which does not have a fixed volume. For example, a balloon, keeping the pressure constant. However, if the volume is fixed, then the pressure of the gas will increase as its particles will collide more often with the walls of the container. So, what is the kinetic particle theory all about? The kinetic particle theory is based on the idea that all matter is made up of tiny moving particles. The higher the temperature, the faster the movement. Smaller particles move faster than heavier particles at the same temperature. When a substance is heated, the particles gain energy, which weakens the forces of attraction between the particles, allowing them to move further apart. The opposite is also true. That is, as a substance cools down, its particles lose energy and the forces of attraction between the particles become stronger and they draw closer together. Let's take a look at this cooling curve taken from the February-March paper of 2025. Remember that when looking at heating and cooling curves, the slanted lines are the ones that show the substance at a specific state, while the horizontal lines show the points where a change of state is taking place, such as melting, boiling, or condensation. So since we are looking at a cooling curve, we start off with a gaseous substance. Therefore, between U and V, the substance is a gas. Between V and W, we have a mixture of gas and liquid. Condensation is taking place. Between W and X, we have a liquid. Between X and Y, freezing is taking place, so we have a mixture of liquid and solid. Between Y and Z, we have a solid. The question says a cooling curve for a substance is shown. which is the cooling curve we have just discussed, and it asks which statement is correct. Statement A says between U and V the substance is condensing, and this is incorrect. As we have stated, between U and V the substance is a gas. Condensation takes place between V and W. That also makes statement B incorrect, because since condensation is taking place, heat is actually being lost to the surroundings. Then statement C says between W and X the particles are close together and randomly arranged. So this describes a liquid. And this is in agreement with what we have discussed, that between W and X the substance is a liquid. So that makes statement C correct. Statement D is incorrect, which says between Y and Z the substance is changing from a liquid to a solid, because between Y and Z the substance is now a solid. Let's now look at the heating curve taken from the February-March paper of 2024. Between 0 and 115 seconds, the substance is a solid. Between 115 to 300 seconds, the substance is melting. Since the substance is melting, we have a mixture of solid and liquid. Between 300 and 400 seconds, the substance is a liquid. Between 400 and 560 seconds, the substance is boiling and we have a mixture of liquid and gas. Then between 560 seconds to 600 seconds, the substance is a gas. The question says that solid X is heated for 600 seconds. The graph shows the heating curve that is obtained. What is the melting point of X? As we have discussed, the substance is melting between 115 to 300 seconds. So this is the point where we take our reading following that horizontal line. So the correct answer here is B, which is 170 degrees Celsius. We will now be moving on to section 1.2, diffusion. According to the IGCSE Chemistry syllabus for examination from 2026 to 2028, by the end of this topic, you should be able to do the following. Number 1, describe and explain diffusion in terms of kinetic particle theory. Number 2, describe and explain the effect of relative molecular mass on the rate of diffusion of gases. So what is diffusion? Can you think of a time when someone walked into your classroom, then mese makuchoka kuti ndiyani ko ane strong perfume? Vele ngubani lo ole strong perfume? Maybe someone on the opposite side of the room even sneezes. This is a result of diffusion. Diffusion is the movement of particles from their region of high concentration to a region of lower concentration. Solid particles cannot diffuse because they can only vibrate at fixed positions. However, when we add a solid to a liquid in which it can dissolve, it will diffuse throughout the liquid. Gases diffuse faster than liquids. Lighter particles diffuse faster than heavier particles. This question, also taken from the specimen paper, says a gas is released at point Q in the apparatus shown. Which gas changes the color of the DEM universal indicator paper most quickly? From our understanding of diffusion and the kinetic particle theory, we know that the gas with the lowest relative molecular mass will diffuse fastest. However, the key thing to note here is that the question is asking which gas will not only diffuse the fastest, but also change the color of the universal indicator paper. Universal indicator paper will change color in the presence of either an acidic or alkaline substance. Although hydrogen is the smallest and will diffuse fastest, it is neutral and will not affect the color of the universal indicator paper. Ammonia is the second fastest to diffuse and is basic, and so will affect the color of the universal indicator paper. Therefore, the correct answer in this case is A. This next question is from the February-March paper of 2025. It says, samples of 4 gases are released in a room at the same time. The gases are carbon dioxide, hydrogen chloride, hydrogen sulfide, and nitrogen dioxide. Which gas diffuses fastest? The relative molecular mass of carbon dioxide is 44. That of hydrogen chloride is 36.5. That of hydrogen sulfide is 33. And that of nitrogen dioxide is 46. Hydrogen sulfide is the smallest relative molecular mass, therefore the correct answer is C. This marks the end of chapter 1. If you found this useful, please like, subscribe, and share with your network. If you'd like to reach out for online tutorials, please contact us on the WhatsApp number given in the comments section below. Ngatisanganire rekare tagwita chapter 2. Salani kahle.